Let's solve problem number 2, finding the area under a curve. So the problem is find the net area of the region bounded by the curve y is equal to x squared minus 4x, the x-axis, and the lines x is equal to 1 and x is equal to 3. Now, we need to, before we solve the area, we need to sketch the graph of the given curves or lines. Now we have y is equal to x squared minus 4x. This is a quadratic equation, which means that the graph is a parabola. And this is our f of x, which is equal to x squared minus 4x. And the vertex is here, and the point of intersection or the zeros, the point of intersection with the x-axis are 0 and 4. So the line and the x-axis is this, and the line x is equal to 1, this one, and line x is equal to 3. So these are the boundaries, okay? And also, for us to identify the area, now let's draw a vertical strip or rectangular strip here. Okay, let's assume that the rectangular strip is here. And let's say, let's use the point at the middle of the rectangle to be x sub I. And at this point, this is the point where the point on the graph, and the point is x sub I, and the y coordinate is f of x sub I. So in this case, we will be using this rectangular strip to determine the area of the shaded region or the region bounded by the curves using the Riemann sums. So using the Riemann sums, we have the area is equal to, or this rectangular strip is equal to uh, the height, which is the f of x sub I, times the width, which is the change of x. The change of x here is this one, that's change of x, okay? And since we made it that there are n rectangular strips, so therefore there must be n rectangular n areas of rectangular strips that we need to add. So that's the summation of f of x of I times the width, which is change of x from 1 to n. And once we take its limit, okay, where change of x approaches to 0, so we make sure that change of x approaches to 0 for us to accurately estimate or get the area of the shaded region. The shaded region is this. So let's try to shade the region, this one. Okay, this region. Yeah, here we go. So this is the region that we're trying to get, okay, to measure. So to get the area of the shaded region, now we already used the Riemann sums, okay, and this is equal, oops, this is equal to, okay, this is equal to the limit as change of x approaches 0, the limit of the summation of f of x to change of x from 1 to n. And since we already expressed the sum of all the areas of the rectangular strips, okay, and we get its limit as change of x approaches 0, then this is equivalent to saying that it is the integral of the function f of x dx from 1 to 3. So that's the boundary, 1 to 3. So this is now the integral that we're trying to solve. So this is equal to the integral of x squared minus 4x dx from 1 to 3. Okay, so in this case, let's solve for the area, okay, or for the integral. So we have the integral of x squared is equal to x cubed over 3, and the integral of 4x is 2x squared. And we are going to evaluate this integral from 1 to 3. And by definition of, okay, the integral using the fundamental theorem of calculus 2 or part 2, we have substitute the upper limit. Okay, we have, oops, let's use blue still. So we have 3 cubed over 3 minus 2 times 3 squared minus, okay, substitute the lower limit. That's 1 cubed over 3 minus 2 times 1 squared. And let's simplify this. This becomes 9 minus 18 minus 1/3 minus 2. So let's simplify this on the next slide. So we have 9 minus 18. 9 minus 18 is equal to negative 9. And this one is equal to, oh, what's this? 1 and 2/3 negative. So this is equivalent to 5/3, negative 5/3. So let's go to the next slide. So we have, going back, so that's negative 9, and the other value is minus negative 5/3, minus negative 5/3. So let's simplify, that's negative 9 plus 5/3. And we have negative 27 plus 5 over 3 is equal to negative 22 over 3. So negative 22 over 3 is our net area. This is square units. Okay, but if we're going to ask, if we are asked about the total area, that's 22 over 3 for total area. And this is for the net area. Okay, so that's the answer.